NASA provided fundamental knowledge. Pluto isn't what you think. What is NASA proposing here? Are they inferring the latest divulgences from the New Horizons space probe, which shows that odd things are occurring on Pluto's surface? One of the most dangerous pictures, for sure, shows something that appears to drift across the outer layer of Pluto. This raises disturbing questions about whether some kind of high-level dark life exists on this faraway world. Or are we dealing with an effectively recognized geological phenomenon? Pluto may be small, but the stories it holds to tell are huge and filled with surprises. When Pluto's planetary status was revoked in 2006, analysts were unaware of the data from the New Horizons probe, which had just arrived at Pluto after years of travel. Since then, we have understood that there is more to this tiny world than expected. How did cosmologists truly come to deny this planet, which we have all, in some way, grown up with? It was once considered a real planet, it had been that way. But after the discovery of several other small planets in the Kuiper belt, astronomers realized we needed a clearer definition of what constitutes a planet versus a dwarf planet or a trans-Neptunian object. How did astronomers deny Pluto? It scored points for its size and round shape, but it shares its orbit with several other objects. Because of this, its orbit is not considered perfect, which was the justification for excluding Pluto from the ranks of the massive planets in the solar system. Many people on Earth think this is a shame. This decision by space specialists caused widespread disappointment. Pluto, now no longer classified as a planet, was a controversial idea for some. The fact that this small, mysterious world has so many fans on Earth led to letters of protest being sent to NASA, even from prominent scientists. Some of these experts had contributed to the very decision that led to Pluto's demotion. Even government agencies received letters from citizens requesting that Pluto be reinstated as a planet. Pluto's planetary status had been with us since the 1930s and was a critical part of the nine-planet solar system, a cutting-edge idea at the time. Then, in 2015, New Horizons sent us the first real images of Pluto. For the first time, the world saw Pluto's actual surface, not just artist renderings in textbooks. Even the verified images from the Hubble Space Telescope paled in comparison to the stunning new visuals. New Horizons allowed us to see Pluto as it really is, an astonishing, well-structured world, and, of course, one with a heart-shaped region. From that point forward, Pluto, the outermost known world of our solar system, gained even more fans. Perhaps one day, astronomers will reconsider, and we will get Pluto back as a planet. The first official images of Pluto amazed everyone. It was a treasured moment when the first data from New Horizons arrived at Mission Control in 2015. Everyone present was aware of the significance of seeing a planet for the first time, one that everyone had heard of but had never seen up close. Computers on Earth processed this breathtaking image from thousands of individual data points and pixels. What the probe revealed about Pluto was a discovery that completely turned our understanding of this distant world upside down. Pluto was far more complex, structured, and dynamic than planetary scientists had previously believed. In addition, this tiny planet appeared to be covered in intriguing features and unexpected natural phenomena. With each new image that New Horizons sent back, this once faint and mysterious world at the edge of the Kuiper belt became something significant. It displayed an astonishing amount of geological activity, leaving experts stunned. Instead of a frozen, cratered, lifeless rock, Pluto turned out to be an intriguing world with vast ice plains, deep canyons, and surprisingly smooth, glacier-like surfaces. It took years for all the data, photos, and revelations from Pluto to reach Earth. Since 2015, we have been astonished multiple times by new insights into this fascinating world. One of the most captivating discoveries is the possibility of walking on Pluto's surface, an idea that seemed unimaginable before. In 2016, a moving image circulated in the media that showed what appeared to be a person walking across an enormous honeycomb-shaped ice field. What could this be? Researchers later determined that the frozen surface was not made of water ice, as on Earth, but of solid nitrogen and methane. The discovery of these peculiar landforms was a major revelation. Scientists now believe that there is a nitrogen reservoir beneath Pluto's surface, where solid blocks of nitrogen ice form and rise due to geological activity. This creates the bizarre honeycomb-shaped patterns and drifting ice mountains. This points to a warm interior within Pluto, a discovery with wide implications. It suggests that Pluto is much more geologically active than we ever imagined. Heat-driven land formations and surface changes indicate a level of internal activity that challenges previous assumptions about Pluto as a frozen, inert world. The presence of subsurface heat suggests that Pluto may have pockets of liquid beneath its surface, possibly resembling underground oceans or magma chambers. The New Horizons geology team, led by William Kinnan, even compared Pluto's interior to an enormous version of Canada's Hudson Bay. Using advanced virtual modeling, researchers believe that Pluto's surface has been shaped by these processes over millions of years and remains highly active today. If you look closely, you can even see an X shape on the right side of one of Pluto's ice fields, likely the result of sublimation, a process where solid material transitions directly into gas, skipping the liquid phase. These extreme temperature shifts on Pluto drive complex geological cycles that continue to surprise scientists. Snow on Pluto, does that sound insane? Well, it's a reality. Pluto remains full of secrets, and the New Horizons mission uncovered compelling evidence of climate patterns and seasonal changes on this distant world. Pluto, which orbits in the remote, cold regions of the Kuiper Belt, has a thin atmosphere composed of nitrogen, methane, and carbon monoxide. And it's still evolving. This thin atmosphere undergoes dramatic changes as Pluto moves along its elliptical orbit around the Sun. At its closest approach, Pluto warms slightly, causing frozen gases on its surface to sublimate into the atmosphere. As it drifts farther away, these gases refreeze, settling back onto the surface as frost. But Pluto's atmospheric mysteries don't end there. Data from New Horizons suggests that its sky is unexpectedly blue, likely due to tiny particles called tholins, which form when ultraviolet sunlight interacts with methane in the atmosphere. These haze particles scatter light, creating a soft, blue glow, an effect similar to Earth's sky but with a completely different chemical composition. Beyond the sky, Pluto's landscapes hold even more surprises. The heart-shaped region known as Tombor Regio, named after Pluto's discoverer, is a massive ice plain dominated by nitrogen glacier. These glacier flow like slow-moving rivers, shaping the planet's surface over time. One of the most striking features is Sputnik Planitia, a vast, smooth ice field that appears to be geologically young, hinting at ongoing internal activity. Perhaps one of the most astonishing revelations is the possibility that Pluto harbors a subsurface ocean. If Pluto's core is warm enough to maintain liquid water beneath its icy crust, it could mean that the dwarf planet is not just geologically active but potentially habitable, at least for microbial life. Scientists speculate that, much like Europa and Enceladus, Pluto might have a hidden ocean insulated beneath layers of frozen nitrogen and water ice. If true, this raises profound questions about life in the outer solar system. Could Pluto's underground ocean contain the right conditions for life to exist? Could the heat from its core sustain complex chemical reactions, similar to those found in deep-sea hydrothermal vents on Earth? While no direct evidence of life has been found, the discovery of a subsurface ocean would make Pluto one of the most intriguing worlds in the Kuiper Belt. New Horizons gave us a first glimpse of Pluto, but it also left us with countless questions. Since its flyby, scientists have continued to analyze the data, looking for signs of additional geological processes, atmospheric changes, and even potential cryovolcanism, volcanic activity that erupts frozen materials like water, ammonia, or methane instead of molten rock. The excitement surrounding Pluto has reignited discussions about sending another mission. Some scientists propose an orbiter that could study Pluto over a longer period, capturing seasonal changes and mapping its surface in detail. Others suggest a lander or even a probe capable of drilling into its icy crust to search for evidence of a hidden ocean. For now, Pluto remains a distant enigma, a world that defied expectations and captured the imagination of people across the globe. Though it may no longer be classified as a planet, its significance in our understanding of the solar system is undeniable. One thing is certain: Pluto's story is far from over. Drastically depending on how close or far Pluto is from the Sun, the changes affect the environment as well as the surface conditions of the dwarf planet. One particularly appealing feature of these natural variables is snow on Pluto. This snow contains primarily frozen nitrogen and methane. Unlike Earth, where snow forms only from water, the extremely low temperatures on Pluto cause the more unstable gases, nitrogen and methane, to accumulate and fall as remarkable snow. All of these associations shape and invigorate Pluto's surface by covering the landscape with new deposits. These disturbances drive other geological developments, like cold movement and perhaps cryovolcanic cycles. The New Horizons research also showed that these seasonal cycles are closely tied to barometric pressure. When Pluto is nearest to the Sun, even a little light is enough to heat up the dwarf planet's atmosphere, causing it to expand slightly and rise. When Pluto moves farther from the Sun again, the environment freezes and sinks back to the surface. This idiosyncrasy leads to a striking anomaly. When Pluto's environment gathers, it could literally snow with snow made of nitrogen and methane. The variations in surface brightness and the distribution of coal deposits further suggest that practically all surface features, and thus scenes, on Pluto are connected to these environmental cycles. Since Pluto's mountains are not made of rock but of ice, which is entirely versatile on this world, the whole surface moves significantly more than our planets. For example, what does Pluto's heart contain? Who might have guessed that Pluto's heart isn't simply warm? Despite its distinctive appearance, this region is also perhaps one of the most breathtaking areas on Pluto. Previously considered Sputnik Plena, the Sputnik Plena region is named after the first artificial satellite, Sputnik 1, which the Soviet Union sent into space in 1957. This huge, heart-shaped ice surface extends across an area of around 1,000 kilometers and consists mainly of nitrogen ice, with traces of carbon monoxide and frozen methane. The bright, almost perfect surface of Sputnik Plania forms a sharp contrast to the darker, more complicated areas around it. Sputnik Plania is a geographical region, a colossal impact structure that was most likely later modified by volcanic cycles. However, this is not the standard volcanic movement on Earth, where magma rises from the planet's interior. Volcanism on Pluto involves cold materials rising from the dwarf planet's interior to the surface. Pluto's heat sources cause nitrogen and other volatile substances to heat up and push upwards, where they freeze and create unique arrangements like this one. Sputnik Plania is strikingly level, which leads researchers to believe that the frozen surface is constantly being renewed by internal cycles. It's likely that convection processes inside the ice sheet form these scenes. Researchers anticipate that there may be a range of liquid water beneath the smooth ice sheet of Sputnik Plena, kept liquid by the heat inside Pluto. Researchers wonder whether forms of life can exist in the subglacial ocean, though not completely impossible. Karen, what is its role? What barely anyone knew before the New Horizons mission is that Pluto had its own moon, and not just one. Charon is Pluto's biggest moon and was discovered in 1978 by the American astronomer James Christie. Charon is extremely large in comparison to Pluto, with a diameter about half of Pluto's. This has led to a significant association between Pluto and Charon, where the two objects are tidally locked, meaning that Charon and Pluto always behave in the same way in relation to one another. Charon's surface is also extremely unique compared to Pluto's, with huge cliffs and massive impact craters. Researchers believe that Pluto and Charon have been trading materials in the form of comet-like objects. Pluto, a controversial status. Pluto, once considered the 10th planet in our solar system, has long captured the imagination of astronomers, scientists, and the general public alike. The astronomer Clyde Tombaugh discovered it in 1930. It remained a symbol of mystery and exploration for decades. However, in 2006, the International Astronomical Union, IAU, reclassified Pluto as a dwarf planet, sparking discussions and debates. Despite this change, Pluto continued to interest scientists and enthusiasts who wanted to learn more about this distant object on the edge of our solar system. NASA's new warnings about Pluto's true essence, encapsulated in the phrase "Pluto isn't what you think," are now drawing renewed attention to this baffling world. This phrase, often combined with compelling statements about the dwarf planet's complexity and significance, hints at discoveries that have emerged through the latest missions, observations, and research. While many aspects of Pluto's composition have been confirmed over the years, our understanding of its mysteries continues to evolve, often challenging our assumptions. Through NASA's exploration of Pluto, especially via the New Horizons mission, we are learning more than ever before. In this article, we will explore the most recent discoveries, scientific advancements, and the growing perception of Pluto as a planetary body. From its controversial reclassification as a dwarf planet to new findings about its formation, atmosphere, and potential for future exploration, we will examine how NASA's research is reshaping our understanding of this cold world at the far reaches of our solar system. The exploration of Pluto. For decades, Pluto remained a distant and mysterious world, barely more than a tiny point of light in even the most powerful telescopes. That changed in 2015, when NASA's New Horizons spacecraft flew past Pluto, capturing the first-ever close-up images of the dwarf planet and its moons. This historic flyby revolutionized our understanding of Pluto, revealing a complex, geologically active world with a surprisingly diverse landscape. New Horizons data showed that Pluto is not a dead, frozen rock but a dynamic world with glacier, mountains, vast plains, and even possible subsurface oceans. The spacecraft's instruments detected an atmosphere composed mainly of nitrogen, with traces of methane and carbon monoxide. Scientists were astonished to discover that Pluto's atmosphere extends much farther into space than expected, interacting with solar winds in a way that hints at ongoing atmospheric loss. Perhaps one of the most unexpected discoveries was Pluto's floating mountains, towering peaks made of water ice that behave like solid rock in Pluto's frigid temperatures. The presence of these ice mountains suggests geological activity, possibly driven by internal heat sources. Pluto's cryovolcanism. One of the most intriguing findings from the New Horizons mission was the possibility of cryovolcanism, a process where volcanoes erupt with substances like water, ammonia, or methane instead of molten rock. Scientists believe Pluto may have had cryovolcanic activity in the past, shaping some of its surface features. The presence of possible cryovolcanoes, such as Wright Mons and Piccard Mons, suggests that Pluto might have once had, or may still have, some form of internal heating. Unlike Earth, where heat is generated by radioactive decay in the core, Pluto's heat sources remain a mystery. Some scientists speculate that subsurface ammonia-rich water could have remained liquid beneath Pluto's icy crust for billions of years, potentially creating an environment where microbial life could exist. The mysterious tectonics of Pluto. Another surprising discovery was Pluto's fractured terrain. Enormous cracks and ridges stretch across the planet's surface, hinting at tectonic forces at work. Unlike Earth's plate tectonics, which are driven by a molten mantle, Pluto's icy surface appears to shift due to the slow cooling and contraction of its interior. These tectonic features suggest that Pluto has experienced significant geological activity over time, reshaping its surface in ways scientists are still trying to understand. The future of Pluto exploration. Although New Horizons provided an incredible glimpse of Pluto, the spacecraft only had a few hours to observe the dwarf planet as it flew by at 50,000 km per hour. Many questions remain unanswered, fueling interest in future missions that could return to Pluto for a more extended study. Some scientists have proposed sending an orbiter to Pluto that could spend years mapping the planet's surface, studying its atmosphere, and searching for signs of a subsurface ocean. A lander or rover could even drill beneath the ice to look for signs of liquid water or potential microbial life. NASA and other space agencies are currently exploring the feasibility of such missions, but given Pluto's vast distance from Earth, nearly 6 billion kilometers away, sending another spacecraft would require significant advancements in propulsion and energy storage. Even with today's technology, a Pluto orbiter would take more than a decade to reach its destination. However, interest in Pluto has not waned. As scientists continue analyzing New Horizons data, new questions arise about this distant world, reinforcing the idea that Pluto, once dismissed as just another icy body in the Kuiper Belt, may hold secrets that challenge our understanding of planetary science. Conclusion. Pluto's story is far from over. Once considered an isolated, frozen rock at the edge of our solar system, it has proven to be a world teeming with geological activity, complex atmospheric interactions, and even the potential for hidden oceans. NASA's New Horizons mission transformed Pluto from a distant mystery into a fascinating celestial body worthy of continued exploration. Future missions may one day reveal even more about this enigmatic world, helping us understand not just Pluto itself but the broader history and evolution of our solar system. Until then, Pluto remains one of the most intriguing and debated objects in space, reminding us that there is always more to discover beyond the limits of what we once thought possible.